In the completing the square video, I kept saying that all the quadratic equation is completing the square. It's kind of a shortcut of completing the square, and I was under the impression that I had done this proof already, but now I realize that I haven't. So let me prove the quadratic equation to you by completing the square. By completing the square. So let's say I have a quadratic equation. I guess a quadratic equation is actually what you're trying to solve, and what a lot of people call the quadratic equation is actually the quadratic formula. But anyway, I don't want to get caught up in terminology. But let's say that I have a quadratic equation that says, let's see, it's ax squared plus bx plus c is equal to 0. And let's just complete the square here. So how do we do that? Well, let's divide, but let's subtract c from both sides. So we get ax squared plus bx is equal to minus c. And just like I said in the completing the square video, I don't like having this a coefficient here. I like I like just having a 1 coefficient on my x squared term. So let me divide everything by a. So I get x squared plus b over ax is equal to, you have to divide both sides by a, minus c over a. Now we are ready to complete the square. And what was completing the square? Well, it's somehow adding something to this expression so it has the form of something that is the square of an expression. What do I mean by that? Well, I'll do a little aside here. If I told you that x plus a squared, that equals x squared plus 2ax plus a squared, right? So if I can add something here so that this left-hand side of this expression looks like this, then I could go the other way and I could say, oh, well, then this is going to be x plus something squared. So what do I have to add on both sides? And if you watch the completing the square video, this should be hopefully intuitive for you. What you do is you say, well, this b over a, this corresponds to the 2a term. So a is going to be half of this, right? It's going to be half of this coefficient. That would be the a. And then what I need to add is a squared. So I need to take half of this and then square it. And then add it to both sides. And let me do that in a different color. I'll do it in this magenta. So I'm going to take half of this. I'm just completing the square. That's all I'm doing. No magic here. So plus half of this. Well, half of that is b over 2a, right? You just multiply by 1/2. And I have to square it. Well, if I did it to the left-hand side of the equation, I have to do it to the right-hand side. So plus b over 2a squared. And now I have this left-hand side of the equation in the form that it is the square of an expression that's, x plus something. And what is it? Well, that's equal to, let me switch colors again. What's the left-hand side of this equation equal to? And you can just use this pattern and go to the left. Or, it's x plus what? Well, we said a, you could view it one of two ways. A is half of this coefficient, or a is the square root of this coefficient, or since we didn't even square it, we know that this is a. b over 2a is a. So this is the same thing as x plus b over 2a, everything squared. And then that equals, let's see if we can simplify this or make this a little bit cleaner. That equals, let's see, if I were to have a common denominator, I'm just doing a little bit of algebra here. See, when I square this is going to be 4a squared. So let me write this. This is equal to b squared over 4a squared, right? And so if I have to add these two fractions, let me make this equal to 4a squared, right? And then if the denominator is 4a squared, what does the minus c over a become? Well, I would have to see if I'm multiplying the denominator by 4a, I have to multiply the numerator by 4a. So this becomes minus 4ac, right? And then b squared over 4a squared, well, that's just still b squared. I'm just doing a little bit of algebra. Hopefully I'm not confusing you. I expanded this. I just took the square of this, b squared over 4a squared, and then I added this to this. I got a common denominator. And minus c over a is the same thing as minus 4ac over 4a squared. And now we can take the square root of both sides of this equation. And this should hopefully start to look a little bit familiar to you now. So let's see. So we get x. So if we take the square root of both sides of this equation, we get x plus b over 2a is equal to the square root of this. So let's take the square root of the numerator and the denominator. So the numerator is, I'm going to put the b squared first. I'm just going to switch to this order. It doesn't matter. The square root of b squared minus 4ac, right? That's just the numerator. That is just that. I just took the square root of it, and we have to get the square root of the denominator too. What's the square root of 4a squared? Well, it's just 2a, right? 2a. And now what do we do? Oh, and it's very important. When we're taking the square root, it's not just the positive square root, it's the positive or minus square root. And we saw that a couple of times when we did the, and you could say it's a plus or minus here too, but if you have a plus or minus on the top and a plus or minus on the bottom, you can just write it once on the top. And I'll let you think about why you only have to write it once. Right? If you had a negative and a plus, or a negative and a plus, they sometimes cancel out, or a negative and a negative, that's the same thing as just having a plus on top. Anyway, I think you get that. And now we just have to subtract b over 2a from both sides. And we get, and this is the exciting part, we get x is equal to minus b over 2a plus or minus this thing, plus or minus b squared minus 4ac, all of that over 2a. And we already have a common denominator, so we can just add the fractions. So we get, and we're going to do this in a vibrant, bold, I don't know, maybe not so much bold, well, green color. So we get x is equal to, the numerator, negative b plus or minus square root of b squared minus 4ac, all of that over 2a. And that is the famous quadratic formula. So there we go. We proved it. And we proved it just from completing the square. I hope you found that vaguely interesting. See you in the next video.